Welcome to Breaking News to Trading Moves. Imagine taking the gross domestic product of a small island nation and just dropping it entirely on custom silicon, automated robotics, and massive electrical grids, all in just 12 months.
Right, yeah.
So we are looking directly at a headline detailing exactly that. Tesla plans to spend more than $25 billion in 2026.
Yeah, and that specific capital expenditure plan prompts an immediate evaluation of where that capital is actually going, who absorbs it and who is burdened by it.
Exactly.
The question investors are asking right now is quite clear. Is Tesla building the next stage of AI, robotics, and autonomous driving? Or is it heading into an expensive cash burn cycle?
Right, because when a company commits to spending over $25 billion in a single year, you have to look at the mechanical reality of that spending.
Yeah, it draws a clear line between potential future market dominance and, well, immediate financial risk. We really need to evaluate the mechanics of the companies receiving this capital and those forced to match it.
So our goal here is to simply look at the headline and then evaluate the market winners and losers across EVs, AI chips, factory automation, and power infrastructure.
Right.
Because if you are evaluating this headline, the very first thing you have to wonder is where the actual cash flows first. To deploy $25 billion, that money, it has to go to suppliers first.
Exactly. It goes directly to the companies building the physical components of AI and robotics.
Right. It's like selling picks and shovels during a gold rush,
Yeah.
I mean, these companies stand to benefit from the spending regardless of whether the final AI products succeed or fail.
Yeah, that is a highly functional way to view the supply chain. Pushing into robotaxis, robotics, and AI training drives demand for GPUs, processors, chip equipment, and just overall semiconductor capacity.
Because you can't train an artificial intelligence model without immense computational power.
Right, exactly. A software algorithm needs a physical processor to perform the math.
So let's read the specific market names associated with this semiconductor infrastructure demand. We're looking at NVDA, Nvidia, AMD, Advanced Micro Devices, INTC, Intel, and AMAT, Applied Materials.
Notice the mechanical breakdown of those names, though. You have companies designing the processors and the GPUs. Nvidia and Advanced Micro Devices specialize in parallel processing.
Which is the architecture required to run millions of calculations simultaneously for AI training. Right?
Exactly, but you can't just, draw a schematic for a chip and expect it to work. You have companies like Applied Materials providing the actual lithography and manufacturing equipment.
Oh, right. They build the machines that bake these microscopic transistor designs onto the silicon wafers.
Yeah, so the demand spreads across the entire semiconductor lifecycle, from the architecture of the AI brain to the physical fabrication of the processors.
Wait, so we have all these cutting-edge chips being printed by companies using Applied Materials equipment.
Yeah.
But a chip sitting on a server rack or a desk is useless. It has to actually go into a physical product, like a robotaxi or a humanoid robot.
Yeah, which transitions us right to the manufacturing floor. The capital expenditure plans go far beyond computational brains. They involve automated factories, production systems, and robotics-related manufacturing.
I mean, a manufacturing floor geared toward advanced robotics requires an entirely different level of automation than a traditional automotive assembly line, I'd imagine.
Right. A legacy assembly line moves at a fixed pace, bolting standard parts onto a chassis.
Yeah.
But a modernized factory floor operates dynamically.
Using machine vision and highly calibrated sensors to adjust manufacturing tolerances in real time.
Yeah, so companies supplying the automation software, the physical controls, and the precision sensors stand to benefit as capital flows into these modernized production systems, especially if the wider industry follows this push.
Let's read the tickers associated with factory automation and industrial technology. We are looking at ROK, Rockwell Automation, HON, Honeywell, EMR, Emerson Electric, and ETN, Eaton?
Yeah, those companies act as the central nervous system of that factory. They translate the digital commands into physical movement. Taking $25 billion and deploying it means a substantial portion filters down into these highly specialized industrial components.
Which brings us to a stark physical reality. All of these custom AI chips, the automated factories, the continuous production systems, they cannot run on thin air.
No, they definitely cannot.
They require massive continuous electrical power. So we have to evaluate power and data center infrastructure as the next category of market winners.
Just how heavy is the electrical burden for this kind of hardware?
The physical reality of AI training, chip fabs, and advanced robotaxi systems is that they demand immense electrical infrastructure. Let's look at the mechanics.
Okay.
A single data center running AI training models does not just pull power to run the servers.
Right. It generates an extraordinary amount of heat.
Exactly. The processors are working so hard that they require continuous high-capacity cooling systems.
Which in turn require even more electricity to operate.
Yeah, and a chip fabrication plant manufacturing custom processors operates under similar, extremely precise environmental constraints. So this level of physical expansion supports companies exposed to grid upgrades, specialized electrical equipment, liquid cooling systems, and overall data center power demand.
It absolutely does.
Well, let's look at the specific names in the power and data center infrastructure space. We have GEV, GE Vernova, VRT, Vertiv, PWR, Quanta Services, and ETN, Eaton.
Notice anything about that list?
Yeah, actually, Eaton, ETN, appears on both the automation list and the power infrastructure list.
Yeah.
So how exactly does power management bridge both the local factory floor and the broader utility grid?
Well, power management operates at multiple distinct scales. On the broader macro grid level, you need heavy electrical equipment and infrastructure to safely route high-voltage electricity from a regional power plant down to the data center or the chip fab.
Okay, so that requires heavy-duty transformers, substations, and utility-scale grid upgrades.
Exactly. But once that raw power reaches the facility, it must be meticulously managed and distributed down to the micro level. It has to be routed safely to individual server racks or, specific robotics lines on the factory floor.
Right, without surging or failing.
Yeah, so a company operating in power management is effectively bridging that exact gap. Plus, cooling systems, like the liquid cooling solutions provided by companies such as Vertiv, are essential. They require precise power management to operate continuously.
So we have evaluated the companies absorbing the capital. Now we must transition our evaluation from the market winners to the market losers.
Right, moving from the companies receiving the cash to the companies burdened by the need to spend it.
Let's start with the EV growth names, including the company doing the spending itself. Why is the company doing the spending actually on the loser list?
That brings us right back to the primary market tension we discussed. When a company plans to spend $25 billion, investors immediately worry about negative free cash flow, rising capital spending, and, valuation pressure.
Oh, I see. Because if that cash is aggressively burned today to build AI infrastructure and robotaxis, the current valuation of the stock is pressured downward.
Yeah, the market discounts the stock because the payoff for that $25 billion is years away, while the financial drain is immediate.
And this pressure extends beyond just one company. Let's read the tickers for the EV growth names facing this pressure. TSLA, Tesla. RIVN, Rivian. LCID, Lucid.
The pressure hits smaller EV companies intensely. They already carry heavy spending needs just to scale their basic vehicle production.
Right, and they operate with highly uncertain profitability timelines to begin with.
Exactly. When the market leader outlines a multi-billion capital expenditure plan, it forces the smaller competitors into a very difficult corner.
Now, what about the traditional automakers? You have companies like Ford or General Motors. They have established global operations and steady cash flowing from selling gas-powered trucks.
Yeah, but that level of spending raises the competitive bar immensely. Legacy automakers face the burden of needing to spend more on EVs, proprietary software, and autonomy.
Right, but they have to fund these advanced research cycles while managing their traditional internal combustion engine businesses.
Which operate on much lower profit margins compared to software or highly automated tech products.
Let's read the tickers for the traditional automakers we are evaluating.
Yeah.
GM, General Motors, F, Ford, STLA, Stellantis, TM, Toyota.
So the executives at these legacy companies have a dilemma.
Yeah, let me challenge you on that specific point.
Mm-hmm.
How difficult is it for legacy automakers to actually justify these massive tech expenditures to their shareholders when their primary revenue still comes from lower-margin traditional cars?
It is incredible.
So this brings us to our final category of market losers: autonomous driving and EV technology suppliers.
To understand why these specific suppliers are at risk, we really have to look closely at the strategy driving the capital expenditure. Tesla's strategy relies heavily on in-house AI, custom-designed chips, and vertically integrated autonomy.
Right, so that $25 billion is not being spent to purchase third-party software licenses from outside vendors.
No, it is being spent to build the physical infrastructure and the AI training data centers internally.
So the risk for the market is that if more automakers try to copy that in-house model, third-party autonomy and sensor suppliers face immediate concerns over long-term demand.
Exactly. Here are the tickers for the third-party suppliers we are evaluating. MBLY, Mobileye, AUR, Aurora Innovation, LAZER, Luminar Technologies.
Those companies build their entire business models on the assumption that automakers will outsource the highly complex components of autonomous driving.
Right, because historically, automakers outsource almost everything. But neural networks and AI driving systems require tight integration between the hardware and the software.
Let me ask a clarifying question for you, the listener. Does an industry-wide push for in-house development cap the growth potential for standalone sensor and autonomy companies? Are they essentially boxed out of the largest contracts?
It absolutely does. It creates a hard ceiling on their growth potential if the highest volume automakers refuse to outsource.
So they are left competing for contracts with the smaller EV companies or the legacy automakers who simply cannot afford to fund their own in-house cash burn cycle.
Right. And since we already evaluated how smaller EV companies face heavy spending needs and uncertain profitability, the customer base for these third-party suppliers becomes highly constrained. The capital flows directly into semiconductor capacity and automated factories instead of third-party software licensing.
Well, we have evaluated the headline and tracked the flow of capital across these distinct sectors. We traced the $25 billion from the initial capital expenditure plan down into the specific suppliers of GPUs and semiconductor capacity.
And we evaluated the necessary grid upgrades, the massive cooling systems, and the data center power demand.
Then we looked at the companies burdened by this spending. The EV growth names facing valuation pressure, the traditional automakers attempting to balance their car businesses with expensive autonomy investments, and the third-party tech suppliers facing constrained long-term demand.
It is a thorough mechanical breakdown of how capital expenditure on this scale impacts the broader market. As we wrap up our evaluation, I want to leave you with a final thought regarding the mechanics of this industry transition.
Go ahead.
If a single company's massive capital expenditure forces an entire global industry to choose between developing highly complex neural networks in-house or relying on fragmented third-party vendors, how will that dictate the timeline and the ultimate safety standards for autonomous driving as a whole?
This is not financial advice or buy or sell recommendations. This is purely the opinion of the author. Thank you for tuning in to our discussion today.